Hello and welcome to The Ruffian with me, Ian Leslie. For this episode, I'm delighted to welcome Benedict Evans to discuss AI and jobs and everything. Benedict is an independent technology analyst who spent 25 years or so thinking about technology-based industries, working in Britain, in Silicon Valley and in New York, where he's now based. He is one of the most respected voices in tech, which is why his newsletter has nearly 200,000 subscribers. In a field dominated by spurious assertions, Benedict is distinguished by his deep knowledge and understanding of the history and economics of technology and by his forensic mind. So I'm really delighted to have him on the pod. This conversation is in two parts. In part one, which is free for all, we talk about the future of AI and jobs. I mean, there's so much overheated discourse on this topic, and Benedict just cuts through it, breaks down the key questions superbly, and gives us a framework for how to think about it. In part two, which is for paid subscribers only, we cover the business of AI itself, the future of the frontier labs, and we talk about the position of Britain in a world where sovereign control over this technology is becoming ever more important. We spoke just a few days after the Trump administration banned the rest of the world from using Anthropic's latest model. We also talk about Benedict's career as a self-employed thinker and what the rest of us might learn from the way he thinks about that. I was recovering from a horrible cold when we recorded this, so I was rather groggy. But it's okay because Benedict was brilliant. I hope you enjoy our conversation. I've noticed that there's a big disjunction between the way that people in Silicon Valley and the tech community around the world feel about AI and everyone else, really. There's huge amount of excitement about it amongst coders and so on. But if you look at surveys of the public, people are interested in it, they're aware of it, but they're not hugely excited about it. And that's reflected in my own conversations. When do you think that gap might close?
So maybe two or three different ways to think about that. One of them is that if your experience of this is sort of opening it every couple of months in the free version or opening it every couple of weeks, it's kind of interesting, it's kind of clever. There's a sort of a portion of people who still think this is about making a paragraph or two of not very good text or making a not very good stock image. And that's rather like somebody in like 1996 saying, oh, I looked at the internet a few months ago, it's just chat rooms. In fact, you can find a video of Jeremy Paxman interviewing David Bowie at about that time. And David Bowie is saying this is going to change everything. And Jeremy Paxman says it's just, random people chatting to each other. Which is a really profound failure to understand the difference between the first things that people are doing with the technology and what the technology actually is. Now, I think a second answer to that would be the thing that's really, really working for this is software development. That's the place where it's found what the tech industry calls product market fit. So with any new thing, you have this sort of iteration of, we're not quite sure what the product is, and we're not quite sure what the market is. And they basically sort of iterate, you change your product, you try to aim at a different market until you find the right combination that works. And so software development with agents has product market fit. It works amazingly well. You can go and ask an agent or a bunch of agents to make a thing, and it will come back with you a couple of hours later with a working prototype that would have taken 3 or 4 people a week. And it will be a prototype. It won't be done. It will be stuff that's wrong. You need to change it. You need to point it in different ways. It's not necessarily what people call one shot. It just works. But you can use AI to make something in software, or to make a microsite, or to make an app, or to make a version of an app that would have taken a bunch of people a couple of weeks and now it just works in a couple of days or in a day with just one person and a piece of software. So that has people sort of running around with their hair on fire, kind of like, I suppose, if you just seen the Wright brothers. And, if you looked at that and said, carries one person, goes a couple of 100 yards, so what? You're kind of not understanding the change. I think the third answer, maybe another way of expressing the previous point, is go back and look at spreadsheets. So spreadsheets used to be paper. In fact, you can buy a padded spreadsheet on Amazon now. And so people get software spreadsheets working in the late 70s. The first successful one was called VisiCalc. And to run this, you needed an Apple II with a monitor and memory and disk drives and so on. And the whole setup cost something over $10,000 adjusted for inflation. Like, we forget how expensive computers used to be. And so they show this to accountants and they say, look, you can change the interest rate here and all the other numbers change. And we see that now and we think, yes, but in 1978, that thing had just done 2 or 3 hours work. And you knew that there would be no... And you imagine doing that on paper, like you change your interest rate. Well, I'm just going to have to recalculate 300 cells, one after another. And if I make a mistake and I get to the end and I realize I've made a mistake, then I'll have to do it again. And so people using this would do like 1-month projects in a week. This is life-changing. Now imagine you're a lawyer seeing this. And you would think, well, that's very clever, I suppose, if you explain it to me, but that's not what I do all day. And maybe my accountant should see this, and maybe I would use it for my timesheet next week, but except setting aside that it costs $10,000 or $15,000 to buy the computer to do it. But that's not what I do. Now, if you came to me and showed me a word processor, then I might start getting interested. If you came to me and showed a legal database, if you showed me, oh, you can change that paragraph without retyping the entire document, or you show me a legal database and I can go and find those cases in 10 seconds instead of going to the basement of the legal library and spending a week there, then I'd get excited. And so I think that's sort of the split, that if you can see the potential of this thing, it's like holding a PC in 1980 or having using the mobile internet in like 2003. There are people who can see the potential of it, even though it really doesn't work. Except there are people who've got this one thing that does work, and then everyone else is kind of looking at a PC in 1980, or trying to use mobile internet in 2003, and saying, "Yeah, I suppose it's cool," and not seeing, no, this is where this is going to go.
That's fascinating. And I this kind of leads us on to the question that people outside of the tech community are getting exercised about, which is jobs, people inside and outside. But and I suppose one interpretation of the way you've just described what's going on could lead to people going, well, once people realize that they're only seeing a very small portion of what AI can do, but if you apply that same principle to lots of other categories, you will see that it's going to take everyone's job away. But it's not as simple as that either, is it? It's you've written about how actually, despite so much of accountancy being automated, accountants, there are more accountants than ever, and so just despite so much of the legal world being run on software, there's no shortage of lawyers. So yeah, what's going on there?
Well, so I'd actually set those examples aside for a minute and kind of come back to them. I think, first of all, 200 years ago, most of us were peasants and we worried about the harvest. And we've spent 200 years automating away jobs. And you can always see the job that's going to go away, and you don't know the new job. You didn't know that there were going to be things called railways. And you didn't know all of the new things, all the new wants and desires and needs that would emerge. And so the first-year economic student will tell you this is called the lump of labor fallacy. They can point to it in their textbook, that the idea fallacy is like there's a finite amount of work, and if you automate that work, or you take that job away, well, then there just won't be any other jobs. This is also a problem with discussing immigration, for example, which is a whole other podcast. And it's easy but the point is, it's easy to see the ones that go away and it's hard to see the ones that will appear. And that's painful. And you get industries that go away and towns that get hollowed out, and you get rust belts and you get unemployment, but it's not permanent and it's not structural. and the net number of jobs doesn't change. You know, people lost their work as typesetters in newspapers. People lost their work, looking after horses. And maybe they loved looking after horses, and maybe they didn't like living in a little teeny tiny terraced house in Manchester, washing soot out of their eyes every morning. And that's all true, but that's a different question to, are there not going to be any jobs anymore? So I think that's one way of looking at this. The second way to look at it is to say this is happening way faster, and say that friction will come quicker and be harder to absorb. That frictional disruption will come quicker and be harder to absorb. I think that's kind of true up to a point. Each of these new technologies compounds. So mobile internet didn't need to wait for the internet. The internet didn't need to wait for people to invent PCs. PCs didn't need to wait for people to invent semiconductors, and so on. So you're always standing on the shoulders of giants. Washing machines didn't need to wait for you to have, everyone had running water, and then you can buy a washing machine. And so it's always quicker. And so this is quicker too, because on the one hand, you don't need to wait for everyone to buy a PC. It's just the internet. On the other hand, it's 3, 5, 10 years to build all the infrastructure and the servers and the data centers to get all of this working to the extent that it might do, which is a point we can come back to. And, big companies, the reason that big companies did not replace all of their staff with PCs wasn't just that PCs couldn't do the work. It was that it takes time to sit down and work out how you would change how your company works. And it takes time to realize all those efficiency gains. One of these now very cliched comparisons is people talk about moving from steam to electricity. That step one is you have this big steam engine that's got conveyor belts and drive shafts going all over the factory, and you replace that with an electrical motor, and it doesn't change anything. And then what actually changes things is when you put power all over the all over the factory, and then you can put the machines wherever you want instead of being tied to the conveyor belts. It's one of those neat stories that might not even be true, but it's a good way of conveying the point. The first thing that happens with PCs is you do the stuff that you were doing without PCs, and then you realize that you can change how you work. And the same thing happens with email and mobile and everything else. And so yes, this stuff is amazingly quick, and yes, it's just a website, but guess what? It takes longer than just going to a website to change how a job works, or to change how a company works, or to build the right tooling to replace all of that. So, maybe it won't take 20 years, but it won't take 6 months. I think the third problem here is that with every previous platform shift, you knew what the physical limits were. So you didn't know what the next iPhone was going to be, but you knew it wouldn't have like a retinal implant and a 1-year battery life. And you didn't know how the internet was going to work. And you go back to the mid-90s, Facebook doesn't exist, Google doesn't exist, Jeff Bezos is a bookseller. But you knew that telcos weren't going to give everybody in the world fiber broadband next year, and you knew that PCs cost $2,000 or $3,000 adjusted for inflation, and there are only 100 million of them. So you kind of knew the physical limits of how this could work. Whereas with generative AI, we don't really have a good theory of why the models work so well. And so we don't know what the next potential developments are. We don't know how much better they will get. Now, there's a sort of sidebar there, which is there's a bunch of people, sort of very noisy but very small bunch of people, who was sort of in 2001 said, well, obviously this isn't going to work, and we don't have a theory for why this would get much better. And here we are in 2026, and that's still true. We don't have a theory for why they would work, but they have got radically better. They do work. They work really, really, really well. They may not scale all the way to human intelligence, which is one definition of what this term AGI. We don't know. Some people think they will, some people don't. We don't have any way of answering that. But the models as we have now are transformatively useful and will change all sorts of stuff in every part of the economy. And so you've got these kind of weird kind of bunch of people who are saying well, do you believe your own eyes, or do you believe my theory from 5 years ago that said it wouldn't work? It's yeah, okay. I can't prove it works, except that there it is. Yeah. It's like, the story of Dr. Johnson kicking the stone.
Yeah, with Bishop Berkeley.
Bishop Berkeley has this wonderful theory of immateriality, that basically existence isn't real and it only exists in your mind. And Dr. Johnson says, I refute him thus, and kicks a stone. Of course, he hasn't actually refuted him. The logic remains intact, hasn't changed by that, but there's the stone. And this is kind of the point here. The models are there, they work.
Is this the first time that a major technology has made such advances without us understanding how it works? Has that happened before?
So I think you could go back and talk. There's a conversation about how wings work, that we don't necessarily have a fully complete description of the physics of how the wings work.
Right.
Um, the other parallel, of course, is the human brain. So,
Yeah.
we know at a sort of chemical level we have some sense of what's going on, but we're nowhere even close to having a proper kind of complete description of what's the difference between what our brains do and what a dog's brain does, and what's going on in a whale's brain, and what's the difference between a dog and an octopus, which has like 8 brains, like spread out down its arms, and so we don't have a good description of what all of that stuff is. And in the same sense, we can describe in a kind of purely mathematical sense what is it that an LLM is doing, and which is again why people say, well, it can't be intelligence; it's just statistics. So, well, that's kind of like looking at our brain. Well, it can't be intelligent; it's just neurons and synapses. Well, yeah, just is doing a lot of work there. You haven't actually proved the point. For all we know, we might just be statistics. We don't know. Or maybe that statistics gets you close enough that it doesn't matter. Again, we don't know.
Yeah. Okay.
There's a line in do you remember that movie In Bruges, where
Yes.
Ralph Fiennes smashes the phone, and his wife comes in and says, "It's an inanimate object," and he looks at her and says, "You're an inanimate object." It's like, well, we don't know. Yeah. Maybe that may be the best way to understand AGI and statistical systems.
Yeah. So let's get back to jobs. So it's complicated, isn't it? Because you're saying, I think, that jobs, that trying to say what's going to happen to jobs by saying, well, this job can be easily replaced because it involves a series of procedures and rules and so on. So therefore, you can easily automate that away. Isn't necessarily that helpful, because the technology is changing the kind of work people do.
I would go further than say it's not necessarily very helpful. I would say it's just self-deceptive nonsense.
Right.
And I'm conscious that I've just told a bunch of Nobel Prize-winning economists that their work is nonsense. There's a joke about the physicists who are asked to predict which horse is going to win a race, and they say, first, we presume the horse is a perfect sphere, which kind of applies here. Look, so I think I would propose kind of 3 reasons why this doesn't work. And none of this is to say that there won't be a bunch of jobs. It's just that are changing. It's just, you can't really predict which ones. And so the first observation is, and which you mentioned earlier, is you kind of go and back test this. So look at accounting. We spent the whole of the 20th century automating accounting with adding machines and punch cards and mainframes and databases and ERPs and PCs and Excel and cloud and everything else. And yet there are more and more accountants every decade. And some of this is this famous Jevons paradox, which everybody looked up on Wikipedia last year, which is basically just applied for price elasticity. So if you make it cheaper to do something, do you do the same amount of work for less money, or do you do more work for the same money, or maybe you do more work for more money because you've got a different ROI? I mean, that's a nice and neat point. The more important point, I think, is if you go and ask what is it that somebody at PwC does all day today, and it's not what they were doing 40 years ago or 50 years ago. The fact that you automated all the stuff that they were doing 40 or 50 years ago, or like a large chunk of it got automated, and that unlocked a whole bunch of other stuff that you kind of couldn't have done before. There's questions you couldn't have asked, there's work you couldn't have done. If it took you a week to calculate a DCF, you'd probably only do 2 or 3 DCS. If it takes you 10 seconds to put in a different whack, then you get a different then you make 50 DCS. And so you certainly see this in finance or law, that if you can find all the precedents now, then you give 10 precedents instead of 1. But you probably bill the client the same. And of course, your opponent has also got 10 precedents instead of 1 and billed the client the same. So basically, you're charging the client exactly the same amount of money, doing 10 times more work in the same amount of time. It might just cancel it out, which is why you get the economist phrase, consumer surplus. That the iPhone swallow Walkmans and dictaphones and portable TVs and radios and 50 other devices, and that doesn't show up in the productivity statistics. You get all this stuff kind of for free. So the first problem is the job changes when you automate it, and you don't necessarily. The second problem is you don't really know what it is that's going on in the job. And so if you think you can kind of go and look at a copy editor and say, well, you spend 30% of your time doing spell check and 15% of your time on the phone with writers and 38% of your time doing this. That's kind of true, but also kind of radically untrue, because that's not really what the job is. And I think, there are some jobs where it kind of is possible to produce a precisely accurate description of what the job is. Generally because the job isn't really a job, it's a task. The task is, to stand in the elevator and drive you to that floor. The task is to, stand at the security desk and check the ID. And you can automate that. But generally, the job of a senior partner at a law firm, or even the job of an associate in a law firm, is much more complex and meshed and intersectional than just saying, well, you spend 38% of your time drafting this and 15% of your time on emails with clients and so on. It's not actually possible to describe it in those terms. And the job changes underneath you. I think the third issue here is, I mentioned copy editors. If we think of like the canonical industry that got completely transformed by automation in the last generation was newspapers. And so if you were to sit down and say, okay, in 1995, is the job of a journalist exposed to the internet? Your answer, you'd have done your scoring system and then you said no. Or even better, is the job of a copy editor exposed to the internet? Again, you'd have done your scoring system and you said no. And what actually happened was that all of those jobs were paid for by a local monopoly, particularly in the USA, by a local monopoly on classified advertising. And in the UK, by a monopoly on a certain kind of reach and a certain kind of audience and a certain kind of advertising. And the internet provided a completely different way of doing that advertising. That wasn't even the same kind of advertising. It was search or social or video. And so the revenue that was paying for you to be an investigative journalist just kind of disappeared. And your scoring of is that job exposed to automation from the internet would not have captured that at all. And so you kind of run through this and you think, well, you're going to score the job of an associate at PwC. And you say, well, what percentage of what they do can be done by AI? Well, again, if you'd done that for journalists or you'd done that for accountants, you'd have said accountants are screwed, and the answer was there's 10 times more of them. And you'd have said journalists are fine, and the answer is probably only 20% as many as there were in 1995. And meanwhile, your scoring system would have been wrong anyway. And so trying to actually kind of do charts and numbers and go through census data and say, well, this percentage of jobs are X% exposed to this, I think is just self-delusional.
Yeah. There are also a lot of big companies where the jobs within those companies are very sort of almost unique to that company, where at least to do them well, you have to have a store of knowledge, implicit knowledge, I suppose, institutional knowledge about that organization and its partners that isn't something you can just sort of take and codify and then apply to lots of other different companies. And I also wonder if that will be a barrier to the diffusion of AI. And
so there's a much more general and kind of more important point here, which is that every previous wave of automation did was it took something that you could describe in logical steps. So it's very hard for you to do a mortgage in your head, let alone do a million mortgages in your head. But it's very easy to write down on a piece of paper, these are the steps that you would follow to calculate a mortgage. And then you give it to a machine and it does it a million times a day, or calculate taxes, or going back a generation, drill us a hole in exactly the same way, in exactly the same place in a machine tool or production line. And so you automate things that you can describe as logical steps. What machine learning did a decade ago with things like image recognition and pattern recognition and like natural language processing and translation was it said, well, there are all these things where you kind of can't write down the logical steps. Maybe you think you can, and then you try it and you can't. So you can't actually describe how you can tell the difference between a cat and a dog. You think you can. And 15 years later, you've written 740 logical steps and it kind of doesn't work. This is the story in, I don't know who is it in Plato that somebody's defined a man as a featherless biped, and then somebody holds up a plucked chicken.
Right.
And so
Plato is all about that, isn't it? You don't actually know what you know.
The point is there were all these questions where you couldn't describe them as logical steps. And what machine learning does 10 years ago, 15 years ago, and now what LLMs do is they say, we'll make it a statistics problem. And so we'll give you 1 million examples of fraudulent credit card transactions. We'll give you 1 million examples of cat and 1 million examples of not cat, and then the machine will build a model to recognize that. And so what LLMs do is kind of generalize that, or hopefully generalize that, and say, well, we'll give you 1 trillion examples of human reasoning. Now, the reason that's relevant to your question is there's all sorts of stuff that isn't in the training data that you don't have examples of. So the challenge for AI is you can automate anything where you have enough training data that you can actually give examples of what you want, and also where you can validate it, where you can check whether it's right, because this is a probabilistic system, not a deterministic system. So it does not produce exactly the correct answer every time. It tells you this is what the right answer would probably look like, which is another way that people get terribly confused, because they say, I asked a question and it was wrong, which is, of course, true. But it's like looking at the web in 1995 and saying, well, that can't replace Photoshop. Or looking at a PC, what was called a micro in the late 70s, and say, well, obviously this can't replace mainframes. And the answer is yes. Maybe in 20 years it will, but it does something else. What LLMs do is they are bad at things that we expect software to be good at, and good at things that software can't do at all. So you can ask questions like, is that credit card transaction weird? Or zoom out a level. Listen to all the Zoom recordings of all our internal one-on-one reviews. Are there new trends emerging? And, good luck doing that with Oracle or SAP. Go look at my Instagram and suggest a new coat for the winter that would kind of change my look a little bit. You could build that now. That would work.
Yeah.
The other side of it is my point is, do you have the training data? Can you validate it? Because there are some answers where what you want is a good answer, and there are some answers where what you want is the right answer. And that's a combination of how do you build the product around that to direct the user down the right paths. And the other side of it is, how much can you validate whether the answer is correct? Is that scalable? Is it mechanistic? Is it practical? So to give kind of two extreme examples, on the one hand, like, supposing you want 50 images of people using your product in different situations. It's a lot easier to get the machine to make 50 of those and then pick the 10 that are good than to make 10 of them yourself. On the other hand, if you want to use this for data entry, you go and read all of those PDFs and pull this number from all of them. Okay, read 100 PDFs, pull the same number from all of them. 98 of them will be correct. But you don't know which 98. So you're going to go and need to check all of them yourself by hand. So at that point, validation isn't efficient. So there is this kind of slightly confused, puzzling space of where does this do what we want? Where is a good answer what we want? Where can we check it? What is the right use cases for making this work? Which kind of comes back to my point about the accountant looking at a spreadsheet versus a lawyer looking at a spreadsheet. Where is it that's what's useful, and how do you make it useful?
Does that mean that it's never going to be that there are certain industries, well, particularly where some sort of critical decision is involved that's going to have some serious impact, which is probably a lot of industries. You'll always need a human to be thinking about whether or not this is actually the right answer.
Well, so since you're British and I'm British, and I would guess a meaningful portion of the audience is British, this is where we mentioned the post office scandal. So this is 1970s technology. This is not AI. This is Fujitsu in the post office. And they build software that has bugs. And they kind of know that there are bugs, but they also think, aha, all these Indian shopkeepers have been stealing from us all this time, and now we know, and now we can prove it. And they get target fixation. And they're not able to step back. I think this is probably the most charitable interpretation, is that they have target fixation and they're not able to step back and say, wait a minute, what if all of those bugs are really bugs? And what if when all these people say, no, the machine is losing the money, they're right? And that's a question of process and culture and education and institutional practice. It's not really a technology problem.
Yeah, that's a fascinating example. Because actually, that's the kind of thing people worry about LLMs doing, the paperclip problem.
Well, this is the thing. Like every new technology gives new ways to ruin people's lives, either deliberately or by accident. You can argue about which the post office was, but the Chinese government puts a facial recognition camera on every street corner in cities to spot Uyghurs. That's deliberate. Then there are ways that you can, that these systems can be doing things and you don't know that they're doing it, or you didn't realize that they were doing it. And then the question is, do you have the process to check that? Do you have the ability to say the computer can be wrong? Which was, I think part of the failure of the post office scandal was a failure of the UK courts. It was a failure in how they handled technical evidence.
Yeah.
That they did not properly challenge when someone from Fujitsu said the machine isn't broken. And they did not. They just kind of took that as though, well, that's unquestionably true.
Yeah. So these new problems are actually the old problems.
Well, they are. I mean, sometimes, I sort of make these kind of comments, and people say, well, but now, this time the machine is making decisions, and machines never made decisions before. And I think, what is it that you think's happening when you apply for a mortgage? Or when you use your credit card, the machine is deciding whether you've got enough money. The machines are always making decisions. The only question, and there's a point at which people set the parameters for that, and there's a point at which people say, I'm going to let the machine make that decision. When you use your credit card to pay your bill in a restaurant, it doesn't go to somebody sitting inside Lloyd's or Barclays saying, does he have enough money? Do I agree with the machine? Is the machine right?
Yeah.
Now, it's a slightly flawed analogy because that's a deterministic system, not a probabilistic system. But, again, so then there's a question, well, where do you use it? How do you think about these things? But there is always a sense, you're always delegating machines. The other side of this, of course, is anybody who's worked in a large organization listens to people saying, but previously you could always explain why that decision was taken, and now you won't be able to. And you think, my dear, sweet, innocent child, do you honestly believe that anybody inside GlaxoSmithKline or Vodafone or the Home Office, if that's still what it's called, could actually tell you why that decision was taken and draw you a little flowchart of why that decision was taken? Yeah. And if they could, it wouldn't be why it was supposed to be taken. It was actually, that person was on holiday and this person is about to quit their job and wants to have a big achievement to point to, and this other person hates them, and that person is like, oh, I can't be bothered with this, I'll do something else. Like this, it's easy to draw like nice theoretical binaries and say, well, this is completely different. And then you say, well, are you actually sure that's how things worked before?
And often bureaucracies take decisions in mysterious ways. I mean, they are as mysterious as LLMs. Something happens. A decision got taken somewhere, but nobody actually quite knows how.
Yes, this is in no sense a comment on UK politics.
It's certainly true of the Home Office. Okay. So, well, before we wrap up this discussion of jobs, are there any other commonly heard sort of aphorisms or things that people say about jobs and AI that really annoy you or that you think are fatuous that we should deal with before
I'm not sure. I mean, I think I don't think fatuous. I think there are fallacies. I think there are statements that people make that are not even wrong. But there is this sort of great unknown that we may get something next week that says we can get better results for a tenth of the compute. We don't know where this technology is going to evolve, so there's always that level of uncertainty. But you kind of have uncertainty at every step. It was very unclear in the early 80s how PCs were going to work. It was very unclear in the mid-90s how the internet was going to work. It was very unclear how mobile was going to work, how the mobile internet was going to work. So you always have this kind of moment of radical uncertainty when you're at the beginning of the S-curve.
So it's just the kind of overconfidence of some prediction. From my point of view, anyway, it just seems like it's hard to say people are definitively wrong when they say things like 50% of white collar jobs.
I would go the other way. I mean, I think you can say there are some things that are kind of seem directionally correct. Like it seems like white collar jobs should be more exposed than X or Y, and then you say, okay, so what about robotics? Maybe warehouse working is the one that's completely screwed and white collar jobs will be fine. And again, it comes back to this backtesting point. So, give me your framework for predicting what AI will do. Now, tell me, would you have predicted what happened to journalism? Would you have predicted what happened to accounting? Would you have predicted Uber? Because if you'd gone back and said, well, what jobs are exposed to mobile and to the internet, would you have had taxi drivers on that list?
Yeah. Yeah.
And so that's a call for humility. And of course, you can turn around and say, well, obviously it's directionally correct, but well, the pox on that. If we'd gone back to the late 90s and you said, well, obviously, media industries that rely on physical distribution are going to have an existential problem. Great. Now compare the movie business with the record business. I mean, the movie business has done just fine. Is functionally unchanged by all of this. I mean, lots of change in the margin, but in the end, the internet did not demolish the movie business, completely demolished newspapers, had more or less no effect on books, demolished the record industry, except the record industry is now back to 3/4 of where it was in 2000 because of streaming. So the devil is always in the detail. And, as long as you're going to say, well, this is obviously going to challenge, and I suppose the tension is, are you making a falsifiable prediction or are you just kind of asserting a truism? Well, of course, this is going to change some jobs more than others. Okay, great. Thank you. What have you contributed to human knowledge by that statement? But as soon as you start making charts and saying, well, X% of people or Y% of people in this profession are X% exposed, then that way lies lunacy.